The last example in section 2.5 is dealing with word problems. And as I mentioned in class, word problems are going to be a continuing theme throughout this course. So we need to get more practice at this and get more experience. If you'd like to pause the video at this time and copy down my example, please do. And I will wait for you to begin. Okay, a movie theater charges $7.50 for adult tickets and $5 for children's tickets. The theater needs to make at least $240 to pay its bills to break even. This is our real life situation because obviously many businesses deal with profits and losses, and obviously you need to sell a certain amount of tickets to start making money once your bills are paid. Now, the first thing that I always recommend that we do is to figure out our variables. And what don't we know in this problem? Well, obviously, it's how many adult tickets that we have to sell. We don't know that. That can change from day to day. And the other one is how many children's tickets we need to sell. Those are the two variables in this particular problem. So let's choose X to be the number of adult tickets, and we'll choose Y to be the number of children's tickets. Now at this point we need to put together an inequality for this particular problem. Well, it says that we charge $7.50 for adults tickets. That's $7.50 per ticket, which indicates slope. So $7.50 times X will give us the total money we make for adult tickets. And I'll just write this down as we build our inequality. Total dollars for adults. That's this part right there. The second part, it says we make $5 or charge $5 for every children's ticket. So that would be $5 times Y. And that would be the dollars for our kids' tickets. And obviously if we add those two together, that will be our total money. The total dollars for adults and the total dollars for the kids. And now it needs to total something. Well, that's where we look at the key words in the problem that say at least. At least tells us that we need an inequality. And that inequality symbol, at least, always means greater than or equal to the $240 that we need to pay for our bills. And there we have built our inequality that we are going to use for this problem. Now I'm going to forward ahead. How many of each type of ticket must be sold to make a profit? Well, I'm going to write down that inequality again. And there's billions and billions of answers to this question. We could sell 1,000 adult tickets and no kids tickets. We could sell 1,000 kids tickets and no adult tickets, or any combination in between. And that is why, as you see on the right side of the screen, I've made a graph, because the graph will be the solution to our problem. Now, as you learned in the last video, in order to graph, it's probably best to find the intercepts. So the first thing I'm going to do is I'm going to find the x-intercept. And I'm not going to rewrite what I did, but we all know we put 0 in for y. And so I'll get 7.50x plus 5 times 0 is greater than or equal to 240. Or 7.50x greater than or equal to 240. And now if I divide by 7.5, you're going to find out that our x value is 32. So that means my x-intercept is the point 32, 0. Now we find the y-intercept. We all know we put 0 in for x. So 7.50 times 0 plus 5y is greater than or equal to 240. And if I solve that, I find out that y is greater than or equal to 48. So 48 is our y-intercept, 0, 48. So there's the two coordinates that I'm going to plot. So the x-intercept is 32, 0, which is going to be about right there. And the y-intercept is 0, 48, which is going to be about right there. And the question is, what type of line do we draw since it's an inequality? Since it's greater than or equal to, it is a solid line between those 2 points. And finally, what side do I shade? Well, I'm going to erase all this bottom stuff. And we need to test a point. And as I mentioned in prior videos, since 0, 0, and I'll put a little X there, since 0, 0 is not on our graph, I'm going to test 0, 0. And obviously this side becomes 0. Is 0 greater than or equal to 240? The answer is false. So therefore I shade the other side of my graph. And what am I shading? I'm shading the answers to how many tickets need to be sold of each type to make a dollar amount that's greater than or equal to 240 to pay my bills. So any one of these, I could put an X, for instance, right here. If I put an X there, that would be 0 adult tickets and 50 children's tickets. And we could test that point, for instance. And if I did that, 750 times 0, 750 times 0 is 0, plus 50 times 5 is 250, and obviously that is a bigger amount than 240. So you can see, for instance, that point will work, or any other points that I want to pick in this shaded region where I'm putting all these X's. You can pick any combination of children and adult tickets in this shaded region, and we will make greater than $240. So I hope that explains that problem. And if you have questions, please ask during class. Now, we've got one more question. The question is, if 20 children tickets are sold, how many adult tickets need to be made to turn a profit? Well, very simply, I'm going to rewrite my inequality for this problem. And I'm going to plug in, it tells you you sold 20 children's tickets. So I'm going to plug 20 in where the y variable is. I'm going to put 20 in here for y. And now we are going to solve this inequality. So I get 7.50x plus 5 times 20 is 100, greater than or equal to 240. Now if we minus 100 to both sides, we get 7.50x is greater than or equal to 140. And then the last thing is we need to divide by $7.50 to find out how many adult tickets we need. And when we do that, we come up with a decimal. Actually, it comes out to be 18.6 repeating. Well, if we sold 18 tickets, if we chose 18, 18 is too low. You're not going to make $240. So we can't sell 0.6 tickets, so therefore we need to round up in order to make our profit. So therefore we need to write x is greater than or equal to 19 tickets would be the correct answer to this problem. We need to round to the nearest whole number. And that is how you solve a word problem using linear inequalities. And as you can see, this is a real-life example, a problem that could be used in a business someday to help them judge how many tickets need to be sold so they turn a profit.